We have an operational amplifier and an Adder-Subtractor configuration with multiple inputs, and we're going to analyze it. That's coming up right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering, lecture service.
In our last video, that is part A of this video right here, was to determine what VN, VP, Vout, and Iout are. And in part B, the question is determine the minimum and maximum values of V2 in order for the OpAmp to not saturate. And what that does is that in the previous problem we had all these four voltages defined, and this voltage we had to find. We didn't know what that one was. So now we're given that the limits of Vout, of course, not saturate. That is to not go beyond plus and minus the input voltage. And in this case, the input voltages are plus and minus 15 volts. So now we're given Vout as plus and minus 15 volts, and we need to know what V2 or V3 can be given those limitations. So now V3 is no longer 1/3 volt. We need to determine what the limiter of the range of V3 is. So this comes right back to the very same equations that we started with. Equation 1 was 28 V sub n minus 21 V1. If you go back, and you'll have these in the previous videos, minus 3 V, I think that's 3 V3. I had to work on my writing skills. V2 minus Vout equal to 0. All right, so then of course, we have two different Vouts here. So we start out, we're probably going to be, let's go ahead and put numbers in and clear this one up here real quick. This is equation 1 for, I'm going to call it 1A. 1A. Vout is equal to plus 15 volt. And for 1B, Vout is equal to minus 15 volts. All right, so in 1A, when we drop those numbers in, and we're going to drop all the other numbers in, we have 28 V sub n plus minus 21 times 1/3 volts minus 6 times 0.4 volts minus Vout for plus 15 volts. And that all equals to 0. Let's see, for that one we plug it in 28 V sub n. Well, let's put the other one real quick. I'm going to get these mixed up too. For 1B, a similar thing. 28 V sub n minus, of course, we already know this is going to be 7 volts. Minus, and that's going to be 2.4 volts. Minus negative 15 volts. That is all equal to 0. All right. So those are the equations we started out with. That was the first equation we started out with. Let's see, when we solve 1A, we get V sub n plus is equal to, let's see, yeah. You can work this out. Just solve for V sub n plus. and that's equal to minus 871 millivolts. And then for 1B, when we solve that one out, it's just a bit of algebra, we get V sub n minus equal to 200 millivolts. Next we have equation 2, which is 59 from the previous problem. 59 V sub p minus 14 V3 minus 35 V4 equals to 0. Now V sub p we have just figured out, we have V4. We know from the start is equal to 0.2 volts. V sub p plus equals V sub n plus, which is equal to minus 871 millivolts. And then V sub p minus is equal to V sub n minus, which is equal to 200 millivolts. Okay, now this is in a balanced, even if we're into the limits of this device, it should still be balanced. Once it becomes unbalanced, then these equations are no longer true. So let's start with, I'm going to call it 2A. And this is where we go 59 V sub p plus minus 14 V3 plus minus 35 times 0.2 volts is 0. Okay, so you can work that out, and what you get is V3 plus equals to minus 3.67 volts. That's at V out equals plus 15 volts. Okay. So the next thing we're going to work as 2B, which is just like 2A, except that we're going to change one of the variables here. 2B is just going to be 59 V sub p minus 14 V3 minus, well, we know that's 7 volts, equals to 0. And then you solve for V3 minus, and that comes out to 343 millivolts. And that is at V out equals minus 15 volts. Okay, so these are the two numbers we were looking for. What are the edges of the V3 input? Properly written, we can probably define the range within which this can operate. So minus 3.37 volts is less than or equal to V3, less than or equal to 0.343 volts. And that's at 15 volts greater than or equal to V out greater than or equal to minus 15 volts. So what this is saying is that these are our limits right here. At minus 3.3 volts or 37 volts put into V3 input, you'll get 15 volts at the output. And it would be right at the limit. And then at V3 equal to 0.343 volts, then you would get V out equal to minus 15 volts, and that would be right at the limit as well. Okay, so that is, so getting used to the graphics pad. Part B.
Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel.
And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.